Today in algebra we're talking about two-sided equations. So the difference in what we have been doing in this is that we have variables on both sides, so an x could be on the left or the right. In the past we've always kept the variable on just one side. So I want to help you recall some things like your goal, remember, is to isolate the variable. Your golden rule is what you do to one side of the equation you do to the other. We learned earlier this week that the next thing to do is distribute and combine. So once you've done all of that, okay, once you've distributed it and combined, then you're going to collect your variables on the left and numbers on the right. Okay? And once we do that, we're going to solve. So let's look at just several examples today. This is really just adding on to the process that we have been doing, just taking it a little bit further. So example number 1, I have 7k equals 4k plus 15. Okay, now what's going on here, let's look on the first side. We've got 7k. There isn't anything that can be distributed or combined, so we're not doing anything else. On the second side, there's nothing that can be distributed or combined. This one has a k and that one doesn't. They're not like terms. So if I want to move all of my variables to the left, I want to move this over here. Right now, it's 4 times k, right? And a 4k positive, the only way I can move over something with a variable is to move the whole thing. Right now it's positive, so to move it, I'm going to subtract that from both sides. The only way I can move it over when it's attached to each other like that. Now I've got 7 minus 4, which is 3k, and that is equal to 15 because those canceled out. Now, what's happening to k? It's being multiplied by 3, right? So I'm going to divide both sides by 3, because that's the opposite of multiply, and k is equal to 5. And that's our answer. We could plug that in and check it, and it should give us a good answer. 7 times 5 is 35. 4 times 5 is 20 plus 15, and 20 plus 15 is 35, so that checked out. Just a good little check right there. Let's look at another one. Example number 2. 5x minus 2 equals 3x plus 4. On this side, there's nothing to distribute and combine. On this side, there isn't either. So let's start moving things around. I want to move my variables to the left. 3k is positive, so to move it, I'm going to subtract it from both sides. Remember, I'm subtracting because it was positive, and I want it to cancel. Over here, I've got 5x minus 3x for a total of 2x. Right? 5 minus 3 is 2, like terms. Minus 2. Now I'm going to add the 2 to both sides because I want to move my numbers to the right. So add 2 to both sides. 2x equals, and I've got 4 plus 2, which is 6. X is being multiplied by 2, so the opposite of multiply is divide. Divide both sides by 2. And 6 divided 2 is 3. And that's all there is to that one. Okay, let's get some a little bit harder. Example 3. 2, open parentheses, y plus 6, close parentheses, equals 3y. Okay, this one there is something to distribute. So I'm going to distribute the 2. 2 times y is 2y. 2 times 6 is 12. And that's equal to 3y. Okay. Now I want to move my variables to the left and my numbers to the right. I'm going to subtract 3y from both sides so I can move it over here to the left. 2y minus 3y is negative y plus 12 equals, there's nothing left over there, so I'm going to write it as 0. The next thing I want to do is move the 12 over. It's positive, so I'm going to subtract 12 from both sides, and I have negative y equals negative 12. Remember, you can't leave the y negative, so to get rid of it, you're going to flip your signs, and y equals 12. And that's all there is to that. Okay, let's look at one that has a lot more going on. Example number 4. 3 minus 5b plus 2b equals negative 2 minus 2, open parentheses, 1 minus b. So let's get that into your view. There we go. Alright, on the first side, there are things we can combine. The negative 5b and the 2b are like terms. I'm going to leave the 3 alone. Negative 5b and positive 2b make negative 3b when I add them together. On the other side, I've got the negative 2, and I'm going to leave that alone. And the second negative 2 needs to be distributed. So negative 2 times 1 is negative 2. negative 2 times negative b gives me positive, because the negative times the negative is positive, 2b. Now I can combine my numbers on this side. Negative 2 and negative 2 make negative 4 plus 2b. Just recopying my other side. I want to move my variables to the left, so subtract 2b from both sides. And I have 3 minus negative 3 and negative 2 makes negative 5b equals negative 4. Move my 3 to the other side, so I can move all my numbers to the right. And I have negative 5b equals negative 7. Divide both sides by negative 5, since that's what's being multiplied by b. And a negative over a negative is a positive, so b is 7 over 5. And that's our final answer. Okay, there are two last things I want to show you, two special cases. So, example number 5. If I have x plus 4 minus 6x equals 6 minus 5x minus 2. This looks like the other problems we've done. There's no distribution, but we do have some combining of like terms. I have x and negative 6x for a total of negative 5x, and then plus 4 since it's not a like term. On the other side, I have negative 5x, and then I have 6 minus 2, which is positive 4. I'm going to start moving my variables to the left, so I'm going to add 5x to both sides. On this side, they cancel. On the other side, they cancel, and now I have 4 equals 4. Now, the reason this is a special case is because your variable disappeared. When your variable disappears, that should give you a red flag. It's either going to be all real numbers or no solution. In this case, we have to check, is this true? Does 4 equal 4? And the answer is yes. So the answer is all real numbers. And what that means, guys, is I can pick any x value I want. Does not matter. Any x value in the world, plug it in, and it's going to make these two things equal. That's what I mean when I say the answer is all real numbers. Let's look at what happens if it doesn't work out that way. So I have negative 8x plus 6 plus 9x equals negative 17 plus x. On this side, we can collect our like terms. So I've got negative 8x and positive 9x for a total of x plus 6 on that side. On the other side, I've got negative 17 plus x. I'm going to move my variables to the left, so subtract x from both sides. Cancel and cancel, and now I have 6 equals negative 17. Is that true? Well, no, it's not. 6 equals 6. Negative 17 equals negative 17. They don't equal each other. So the answer here is no solution. Guys, this happens when there is absolutely no x value that I can plug in and make these two things equivalent. That's what's happened here. There is no answer. That's why the answer is no solution. Okay, your assignment for this is A8, and it's page 103. It's numbers 2 to 11, and you're going to do all of those. You need to be sure you really understand this because this topic is really important for the rest of algebra. So do some good practice here. We'll practice for a couple days. If you have questions, be sure to come to tutorials or let me know.